Welcome back. This is an Aleks homework video on using the conditions of spontaneity to deduce the signs of delta H and delta S. Okay, when you got to this thermodynamics section of your book, you realized that G, H, and S are all related with an equation. Okay, so we know that delta G is equal, so Gibbs free energy or the available energy is equal to your enthalpy, which is delta H, minus the Kelvin temperature times the change in entropy, which is delta S. So I know that spontaneous means that I have a negative Gibbs energy. So when delta G is negative, it's spontaneous. All right, so I'm kind of tweaking this problem to find out when is G negative. Is there any way that I can find out when G is negative? Right, so what would the other ones need to be in order for G to be negative? Now there are two that are easy and two that are hard. So I'll do the easy ones first. So let's say that I've got a positive and negative. So my enthalpy, which is delta H, is positive. My entropy, delta S, is negative. All right. Well, I've got negative T delta S, which means that negative is multiplied by a negative, giving me positive. So the first part of this equation is positive, the second is positive. That means delta G has to be positive. If delta G has to be positive, then it's never going to be spontaneous. If delta G is always positive, it will never be spontaneous. So when it tells you that it's spontaneous, it can't be this configuration. All right? So let's look at the other easy one. What if entropy is positive, but enthalpy is negative? All right, that means that the first one is negative, and since you're changing the sign of the second, they'll both be negative. Well, if both of them are negative, then I'm sure that delta G is also negative. If delta G is negative, then it will always be spontaneous. So if you have a situation where it's always spontaneous, then this is the configuration you're going to put. You're going to put that the entropy is negative, and you're going to put that the entropy is positive. All right, so those are the two that I would consider easy, because there's no other way to make G something else. The other two are harder, because if you have positive and negative S's and H's, I don't know what the resultant is going to be. I don't know whether there's a little bit being subtracted from a big one, leaving you some small, or whether there's a lot or a little. So it would be very difficult to make some guesses at this. So what we're going to do is we're going to try to make one of these go to zero, or at least comparatively nothing compared to the other one. So either make one so small that the other one essentially is all you have, or make one so big like that the other one is essentially nothing. All right? And really the only way you can fiddle with this is the temperature. If you can make the Kelvin temperature towards zero, okay, make it towards zero, then you have a very low temperature. Well, then negative 0 delta S is 0. And that second part after the equal sign essentially goes away. All right? Which makes that not exactly equal, kind of fudgy equal, that delta G is essentially equal to not just the first, or not the first and the second, but just the first. So if at low temperatures, we're really more interested in knowing what the enthalpy is. And if the enthalpy is negative, then G is negative. If the enthalpy is positive, then G is positive. Okay? So I simply put them both negative. Because can you see that you're going to have four possibilities? You're going to have positive, negative, negative, positive, negative, negative, and positive, positive. Those are your four possibilities. So even though that negative T delta S, who knows what it is, I simply put them both together, equal negative, negative. All right? So at low temperatures, if you have a negative enthalpy, then you have a spontaneous reaction. or is spontaneous at low temperatures, then you can guess that your enthalpy is negative. And I just put them both negative. The other possibility is if you have high temperatures. So if you have high temperatures, then what's happening is your T is so big that your negative T delta S is so much bigger than your delta H that I essentially ignore delta H. Okay, so I just think of it as just the one. I'm making the temperature so large that the other one dwarfs in comparison. All right, so the other possibility is positive, positive. Again, do you see the 4? Positive, negative, negative, positive, negative, negative, positive, positive. Those are your 4 configurations. So at high temperatures, as long as your entropy is positive, then that since you have a negative sign there, your G will be negative and it'll be spontaneous. Okay, so it's spontaneous at high temperatures. So let's look at these 3. I already see that the letter C, I can't tell. It's unknown. It's unknown to me because it doesn't tell me anything about spontaneity. The spontaneity is required for me to use this formula of delta G. If delta G is negative, it's spontaneous. If delta G is positive, it's not spontaneous. So when they tell me nothing, they told me the rate, but the rate is to confuse you. The rate means nothing. It doesn't tell you anything about whether it's spontaneous or not. Look at B here, where it says such and such, but the rate proceeds faster. It doesn't matter. Totally ignore that. It means nothing at all. All you're interested in is this something spontaneous or not? And if it's spontaneous, is it at all temperatures? Is it low temperatures? Is it at high temperatures? And then you can guess the rest. Okay? So the first one, it says that it's spontaneous except for above 112. That means all the low temperatures are spontaneous. So if it's low temperature spontaneous, I look down at number 3, negative, negative, and I put negative, negative, right? B is the reaction is spontaneous above 88. So since it's above 88, then it must be at high temperatures. And if it's high temperatures, it's positive, positive. And just like I said before, because they didn't give me anything about spontaneity, I haven't the slightest idea of number or a letter C. All right. So hope this helps you. It looks hard to me, but I think if you kind of think it through and at least I would make myself a graph for this before I answer the question. Hope it helps.